All right. Welcome, everyone, at my talk about continuous deployment to the cloud using Spinnaker. I know there are some great talks currently happening as well in the other rooms, so I'm very happy that you guys chose this talk. First, who am I? I am from Belgium. I'm Andreas Evers. So I think I have to put this back in. Yes. Andreas Evers. I love open source, work for Ordina, which is a consultancy firm in Belgium. I'm a Spring contributor. I love to work with Spring. With continuous deployment, of course, of microservices. So, as I said, I work for a consultancy firm, which means I see a lot of different clients, different customers, different cases, and different maturity levels in terms of deployment to cloud. Right? What we often see in so-called digital transformations is that there are three big parts that are being implemented, three big trends. The first one being obviously DevOps. I suppose you've all heard a lot about DevOps. But not just the cultural part, but also the practices part, so the technical part. This isn't just about deploying and automation for deployment, but also test automation. So trying to automate everything end-to-end is key to DevOps and sustainably going to production as fast as possible. Okay, so this is the first big trend that we are seeing in many of the companies that we work for. And the second trend is something we all love as developers, I suppose. Microservice architectures gives us a lot of freedom, a lot of flexibility, but also some pitfalls that we have to think about, obviously. But without microservices, it's hard to go quickly to market. Okay, microservices I see as a technical representation of what DevOps brings as a culture. Because DevOps organizes the teams in product teams, cross-functional. Everybody required to get an idea into production, we put together in one team, and focusing around a specific product or specific feature set, which could be linked to the bounded contexts in microservices. So in that sense, it really fits well together. And the third thing, to really be able to quickly go to production, you could do it on-premise, but really a platform to deploy on. This could be an on-premise cloud, but also obviously the big cloud providers out there, or an orchestration framework. So this kind of infrastructure movement is crucial as well. So the three trends, DevOps, microservices, and cloud, or platforms as a service, are crucial in this digital transformation world. Okay, so we've done a lot of this stuff with our customers, some customers further than others, and we've really we've seen some pitfalls that we have to try to avoid in the future, some lessons that we learned, and I'd like to share them with you, the things that we noticed that could be better. So lessons learned. First one, if you start doing DevOps, microservices, cloud deployments, then you see that your deployment frequency literally explodes. It's not really like, it's not something you can manage by doing the traditional operational work or keeping traditional release management or change management with a board that has to approve things. It doesn't work like that. You really have to start automating that as well and making sure that you don't have any bottlenecks when you go to production. So this is something which you will see if you do microservices, obviously, because you have smaller components that can go to production quicker, and self-service in the teams, which means they have the autonomy to decide when they want to go to production. So this means that for some companies like Netflix, for instance, they deploy currently 4,000 times per day, 4,000 deployments in a single day. And every year, they increase this with 100%. Okay, so you can imagine that traditional practices, they completely fail if you have this kind of volume, this kind of amount of deployments. But it can also mean for our companies, smaller companies, we are not Netflix often, I'm not talking for everyone, I suppose, but for the clients I work for, this also happens relatively to their scale and their size. Okay, the second lesson we learned is that cloud deployments are complex. Okay, it might seem that this is just the same as deploying on-premise or deploying on a VM that you know, but it's really not. Here you can see different actors, different teams, different people who have different changes, and they want to deploy this in different services over different providers. This can happen. Different cloud providers, but definitely in different regional zones, availability zones. Okay, if you combine all this together, Ansible will probably not cut it for you. You could try, but you'll see that it's going to be the next level of complexity. Okay, so having some kind of platform that supports this is crucial. I think it can really help you a lot. Okay, so cloud deployments are really complex. What we also saw is that things will go wrong. Because they're so complex, it's difficult to make sure that you'll always be exactly as intended, so that the deployment will always succeed. So then we have to think about rollbacks. What will we do if things go wrong? And we have to make sure we can go back in time pretty easily. Okay, but that's not as easy as it might sound. Okay, so having the possibility to click on a button and to roll back, that's something I think very important to have. Okay, and if you don't have this, you'll be in a lot of war rooms, I suppose. Then, do you guys know this page? Anyone? Anyone who knows this? All right, one from GitHub, exactly. This is the unicorn from GitHub. It's when GitHub is down, they show this page. Okay, they kind of want to make you feel like this is super special, never happens, right? It never goes down, but it will go down. Okay, your deployments will fail and you'll have downtime. But the important part is that your blast radius is as small as possible, so that the least amount of people are impacted by a certain failure or downtime. Okay, so making sure you deploy during the right time frames, when traffic is low and when people are in the office to be able to support the problem at a given time is very important as well. So that's a lesson we learned. If you deploy at night because some build process is triggered at night, then it's probably going to be bad if you don't have anyone in the office and everybody has to be woken up. Okay, or if you deploy during peak times, it's also not really a good idea. All right, so these are some lessons that we learned the hard way by doing it wrong. And there are some continuous delivery or continuous deployment principles that we can distill, not just from our experiences, but also from the community. That if you follow these principles, then any decision that you make while respecting these principles will actually be an okay decision. Because those principles are most important. And the first one of these principles is, you probably know this already, immutable infrastructure. Make sure that your infrastructure is predictable, right? That your infrastructure is repeatable, that you don't have snowflake environments. So that the environment on dev, for instance, it might look as the environment on acceptance or QA or whatever you might call it, but there's just some small tweaks that the infrastructure people did to make it work on QA. I mean, you don't want that. Okay, so you want to have robust environments that are very predictable and the same artifacts deployed on all different environments. Okay, so then that's not just about the artifact that you deploy, but also your build process, your test process, your deployment process, and validation process should all be very deterministic. Okay, we should be very clear about what we expect to happen. And it should really follow that process every time, always the same process. It's kind of straightforward, immutable infrastructure, and we do this a lot. We do this by using Docker, for instance. So who uses Docker? That's a lot. Who uses Rockets? RKT? Nobody. But who uses VMs where the application is baked into the VM as an image? Anyone who uses that? All right, cool. Netflix does this as well. They also use containers now, but it's also immutable infrastructure as you keep that image as a immutable or unchangeable source. Okay, so that's the first principle. Make sure that everything is immutable and that everything is as code. So configuration as code and so forth. Okay. The second principle, deployment strategies. This might be unfamiliar to people who are not in the operational sphere, but we are more and more getting used to these kind of strategies. So blue-green strategy, blue-green deployments, Netflix calls them red-black, and since we're using Spinnaker in this talk, this is kind of based on Netflix because they built it. So you're going to see red-black coming back once in a while because their initial logo was red and black. Now it's red and white. So they still call it red-black. Anyway, blue-green is about having a new feature or a new version of your application, spin it up next to the existing one. Don't just undeploy the existing version and then deploy the new version. That wouldn't be blue-green, that would just be deploying a new version. But that would mean you probably have some downtime, and it's probably also not that easy to roll back. But with blue-green, you just deploy the new versions next to the existing version. And the load balancer on top of it will be your switch. So you'll use the load balancer to simply say, now all traffic will go to the first version, and we'll switch it over to the new version. So everyone will now see new functionality on the new instances. Okay, and the big benefit here is that you can switch back whenever you want. It's just a question of a toggle. Okay, so that's a really useful approach. But we can go one step further, and that's called rolling blue-green or rolling red-black. As you can see here, the load balancer is still used to switch over traffic, but you're not going to do it all at once, and you're going to have some kind of validation phase in between. So you might expose the new functionality in one instance, and then have a smoke test, for instance, or just validate manually. That could be as well, like your functional analyst or your tester could manually test this. Probably not recommended, but still, you could do this. And then, based on that result of that validation phase, add an extra instance. And at the same time, bring down some other instances of the V1, for instance. So you could do this, and that'd be already an improvement because you'd have some kind of, you'd be limiting the blast radius, right? Like I talked about before. Here you'll just have like 2 instances, so a small percentage of your user base routed to that one, and you'll be able to actually see what's going on there. And the next step would be the canary testing or canary deployments. And with canary analysis, you're actually going to make that validation phase completely automated as well. So the validation phase I talked about before was smoke testing or some light validation. Here you're going to use metrics, telemetry from the application. For instance, amount of errors in the logs, or you could check the traffic that is routed to some functionality, or HTTP codes, error codes that you might receive, or CPU usage, memory usage. These are all statistics, or these are all metrics that you could combine. You could count them up in some kind of algorithm, and then calculate a score based on this. And based on the score that you get from that, you can compare it to the score of the previous deployment, the baseline. And if that deployment was more successful or was at least had a higher score, then you could wonder, like, is this really something I want to keep rolling out? Okay, is this something that I want to, do I want to go to the next phase of the rollout? Okay, so the rollback that you could do if the score is too low, if there's not enough confidence, could also be automated, and that's the idea behind canary releases as well. You'll automatically, based on metrics, roll out or roll back. Okay, all completely automated. And that's kind of the Valhalla of automated releasing, I would say. Okay, so these aren't just simple deployment scripts that you could write. These are real strategies based on very complex systems that you use for analysis. Okay, I suppose this is something different than most people do already currently when they're deploying a new version, and that's giving you a real benefit. Okay, so that's an extra. That's a second principle that we must think about if you want to deploy. Start thinking about strategies. Okay, how do you really want to deploy this? Okay. Then automation. We talked about DevOps, of course, but this here means let's automate the deployment completely. So here you can see an example of a deployment pipeline. So there's really all kind of stuff here. Like you have deployed something on test environments, so you want to see which image is deployed there, and you want to use that one. Then deploying a canary, having a cutover to see if the canary was successful or not, right, which is a separate cluster. Then if you deploy on production, do it in a blue-green fashion, right, so the full rollout, but then you might even do it rolling if you'd like. Tear down the canary cluster because you're confident about release. Wait a couple of hours, and then destroy the old version of production. Okay, so this is a typical deployment pipeline that you could be writing. But if you look at all these different phases, for instance, the deployment to production in a blue-green fashion, what does that really entail? As you can see here in Spinnaker case, Spinnaker really does a lot of stuff. Spinnaker will have a bunch of steps that it goes through to ensure that everything is handled correctly and that you have a consistent deployment after the entire pipeline is ran. So these steps here, for instance, deploying on default, shrinking the cluster, the existing cluster, disabling this cluster, and then scaling down. And then disabling clusters also consists out of tasks that it runs. And it checks the health providers, checks if the cloud is in a consistent state to move further. Then disabling the cluster, monitoring the disable itself, forcing a cache refresh because it works a lot with caches, obviously, and waiting for the cluster to disable, and then again forcing a cache refresh. So all these tasks themselves have a couple of operations. For instance, the disabling of the cluster, it alters the forwarding rules of the load balancers, it changes the target pools, and it removes eventually the instance. Now all this stuff, you could probably write this in Ansible. You could probably write this in scripts. It's possible. But having something out of the box as a platform, I think it's really powerful to have this without having to write it yourself, because most of the times these scripts that you write, they're brittle and they're only tested by actually deploying, by actually executing the pipeline. Right? So, but at that time it might be too late because there might be an issue in it. Okay, so this is a typical pipeline, and I think making sure that everything's automated end-to-end is crucial and a very important principle in continuous delivery. Then another principle is operational integration. Okay, so we talked about canary deployments, and when we are deploying, what do we actually do in that sense is we're looking at operations. We're looking at what it is, what's happening on production. So traffic is routed to one of the instances, and we're running an analysis on top of that. So we're looking at how this instance is behaving. So really the deployment is taking information of the operational side and using it to determine to go to the next step or to roll back. Okay, so this integration is important, but also vice versa, in the other direction. When your deployment is finished, you're running on production for a couple of days perhaps, then it's still important to be able to track back to the deployments. How did the deployments go? What actually happened during the deployments? Which strategy did we use? But also, which code commit actually happened? Which change set is linked to the current version on production? Having a really easy way to track this back, I mean, I think we can all agree this is a very important benefit to have. Okay, so this integration is important to bake into your system as well. And needless to say, these principles are all supported by Spinnaker. This is not really a sales pitch, I hope, but it's a tool which was built by Netflix and is open source, but all the major cloud providers are now buying into it. So I think it's a really good candidate for making sure you have multi-region and multi-cloud deployment possible without having a steep learning curve. Okay, so I talked about Netflix, who built it. So who else is working on this? Google is really heavily invested in this. They see Spinnaker as their main continuous deployment tool. And Lars Wander from Google is a really nice guy and it's really helpful. So if you're on the Google Cloud Platform, then I really suggest that you have a look at this tool because it's super well integrated. But also Azure from Microsoft is integrated. Pivotal, there's a lot of Pivotal guys here. Cloud Foundry, Pivotal Cloud Foundry is integrated as well. Oracle Cloud as well. And then some other companies, big companies like Target, for instance. And Veritas, I mean, they are also contributing actively to this platform. For their specific needs, perhaps, but it's still great to have such a big community behind this, with the major cloud providers all going forward for this. Armory, for instance, is a software as a service solution for Spinnaker, so you don't even have to spin this up yourself, you can just use it from their side as well if you'd like. So which companies are using this? There's a whole bunch of them. We're using it at our clients as well, but like for instance, Waze is also using it. And they have a really nice talk on YouTube about how they make sure that they're heavy traffic, because they're a really high-scaled company, how they can support deployments which don't break their app continuously, of course. Okay, so which clouds are supported? I listed a few, but there are actually more. So Amazon, AWS, of course, because Netflix is completely on AWS. OpenStack, Azure, Oracle Cloud, and then from Google, Kubernetes, because that's mostly developed by Google. Compute Engine, so the EAS version, the managed Kubernetes on Google, Container Engine, and App Engine, if you want an application platform as a service, I suppose. But also DCOS, Mesos is also supported, and even on bare metal, you can deploy images. Okay, so I suppose this gives you a really easy way to switch providers. Why? Because this adds an extra layer on top of the cloud primitives of each of these cloud providers. So while, for instance, AWS is talking about AMIs for images, Compute Engine talks about GCE images, right? And they are just a little bit different. What Spinnaker does is it adds a layer on top of that, an abstraction layer where you don't have to care about these specific providers, and you can write your pipelines independent of the implementation of these providers. So if you want to deploy, for instance, your dev environment on Azure, or your QA environment on Amazon, and your production on Azure, that would be fairly possible, no problem. Or if you'd have the East Coast of America on Amazon, and the West Coast on Google Cloud Platform, that's also really easy to do. All right. So what does this really look like, the internal structure of Spinnaker? Spinnaker consists of a couple of microservices, and they're all written in Spring Boot. That's pretty cool about that. It also allows you to go into Spring Boot and into one of these services and to really understand what's going on in these services. So who's using Spring Boot right now? Right. So I think about 80%. So having this architecture available is, for me at least, it was really easy for me to contribute to this or to start understanding the individual components. For instance, you've got DAC, the Angular application. That's just the UI, and it's written in Angular, and most people these days know Angular, I suppose. Gate is the API gateway, so all traffic or all the calls from the DAC application go in there, or any callers that use the API also come in there. Then we've got Cloud Driver, this guy here. That's the abstraction layer towards all the clouds. So this is where the magic happens. If you compare to, if you want to use different cloud providers, this is where the integrations happen. Then which one am I forgetting? Orca, that was another one. It's an orchestration engine. That's basically for the operations of the pipeline to make sure that all happens correctly. Roscoe as well, that's the bakery, Roscoe. So this guy here, this allows you to bake your images like AMIs to really put your application in there as an immutable image. Then Igor is used to trigger pipelines. And then we've got front 50. Front 50 is used to persist the metadata. All right, so a bunch more of these services. But one more I will talk about later is Halyard. That's a really interesting one to get up and running in a really easy fashion. Okay, so a bunch of microservices connecting to each other, or at least Spring Boot applications. Depends what you really want to call a microservice, I suppose. Okay, so pretty familiar, right? So let's take a look at what Spinnaker does, what kind of features that it offers. Aside from, of course, a pipeline and running the pipeline, I think it can do a lot more, and that kind of brings us back to lessons learned and to these principles that I talked about. So the first one is it's easy to plan deployments. So if this, for instance, is your traffic graph of your application, you could see that between these time frames, you'd have a lot of traffic, and between the other time frames, you have less traffic. Then in Spinnaker, you could set here, I only want to deploy between 10 and 15, or between 10 and 16. And you could put this as well during office hours, so you'll be sure that there are no deployments happening when nobody's around. Okay, but you could then also specify, like, okay, these are office hours, but we only want to do this at noon, because then we know that nobody's using our application, or at least a lot less people. Okay, that's interesting, because you could do all the steps necessary to get to the point where deployment has to happen. Let's say you do all the different environments up until QA, where you just have that big red button that the manager has to press, for instance. Or you just hold your deployment for production until that time frame. You don't have to do all the work actually at noon, in that sense, and then you can just roll it out. Okay, so that's a useful feature, I suppose. Whoops, went too quick. We have integration for chaos monkeys as well. Who knows the chaos monkeys from Netflix? Simeon Army? A couple of people? Okay, so the chaos monkeys, the idea behind it is that you start pulling plugs and see what happens. Okay, try to destroy your environment. You could do this on QA or on dev or on test or on production if you got the guts to do it on production. I know some people do it. I just do it on QA. But this allows you to really make sure that people understand the philosophy of DevOps, I suppose. If people think that everything will be fine on production, the fallacies of distributed computing, for instance, then they won't really start building robust applications. The resilience won't be built in. So by making sure that people know that something will go wrong because it is being triggered to go wrong, they will no longer believe in these fallacies that everything will be fine. Okay, because in cloud deployment, in clouds, public cloud at least, things will always go wrong. Okay, there will always be something. Okay, but making sure that your application is robust against these failures will help you to overcome these failures in an easy way or make sure that they never happen to you. Okay, so the chaos monkeys, they are the little monkeys that you let go in your ecosystem, and they try to ruin everything for you, and you can schedule this through Spinnaker. Okay, I think it's important to mention as well that you still need to do a verification whether you did a good job against the monkeys. Okay, so I saw some people setting up monkeys and then just ignoring them. Right? They would probably fail some systems and nobody would probably know that something is down, or people wouldn't really realize. That's pretty bad. Okay, so having a verification phase or an assertion phase is important. So aside from chaos monkeys, there's also the canary analysis. I'd have to mention that this integration here that you see on the screenshot is not yet in the master. It's not yet fully released, but it will be by the end of the year, if I can believe the Netflix guys. But it should be. What you can still do is, I'll show a demo and I'll do a canary deployment, but here you can see the score. Okay, so the score is really the algorithmic behind it, the calculation of all the metrics. That's going to be open source pretty soon. Okay? Now, there are some tools out there as well that are similar to Spinnaker, I suppose. Terraform Reformation. Anyone using any of these tools? All right, so it might seem a little bit the same, like or Helm for Kubernetes. It's also kind of things that can set up environments or set up tools. But Spinnaker has a different approach, different perspective, and they can work in conjunction. It's not mutually exclusive. So Spinnaker really focuses on delivering applications as fast as possible through a robust pipeline. Okay? While Terraform and CloudFormation, they are really focusing on setting up complex tools in a predictable way as code, a configuration as code. It's kind of a different perspective. Okay? You can, for instance, you could use Terraform or CloudFormation to set up Spinnaker, because Spinnaker doesn't have to be continuously delivered. Okay? But if you want to continuously deliver applications just as microservices, you really want to continuously deliver microservices, then Spinnaker is really the tool to use, I suppose. And then Halyard, the microservice I was referring to. Halyard kind of makes sure that you don't have a hard time setting all this stuff up. Because you have all these microservices in the internal structure, which I showed before. They all have separate versions. If you have to manage that and make sure that the versions work with each other in a good way, then it could get nasty. Okay? So Halyard makes sure there's a bill of materials, just like there's a bill of materials in Spring Boot. Spring Boot also has the parent POM or the BOM that you could also use, which will help you to make sure that all your dependencies, you don't need to specify versions, but you'll just get a working set of dependencies that are tested with each other. It's the same thing that Halyard is doing for Spinnaker. Okay? It allows you to easily install, upgrade, configure, and validate your complete deployment. So it's actually just a configuration or installation tool and a deployment lifecycle management tool for Spinnaker. Okay, this was recently added, I think 2 months ago, something like that. So, and I really think this is already a huge benefit if you want to get up and running with Spinnaker. So installing Spinnaker for the demo, it took me about 10 minutes to get completely up and running. And that was on Google Cloud Platform. Okay? So that's a big benefit. What's coming up? Canary strategy. So I talked about the canary deployment. The score, that's a separate strategy. So that's not yet merged into the master. You can turn it on, but it's not really fully supported yet. So that's coming up by the end of November, maybe December. The rolling blue-green strategy, so you can simply select that strategy and be done with it. That's pretty nice to have it out of the box. Declarative CD, that's one which I'm really looking forward to because we talk about immutable infrastructure and having everything as code. But then I'd like to have my Spinnaker pipelines just like I have my Jenkins pipelines. I want to persist them in Git, and I want to have them versioned and audited. Okay, so having this functionality available, I think it's crucial to practicing what you preach. But Spinnaker is working on it. It's not there yet. So you can now import JSONs and put that in Git yourself, but it's not really integrated. And declarative CD goes one step further. It allows you to have templates for deployment pipelines that are typical, for instance, Netflix or Google or Microsoft see as a typical way of deploying an application on their platform. You can just use that out of the box. So that's something cool. And also some more operational monitoring for Spinnaker. Okay? So, Armory, the company that offers Spinnaker as a service, they kind of put this stages of software delivery evolution in the slide. And I think it's a nice conclusion before I get to the demo. Like the different stages that you can see in a company, the different maturity levels, before you really go into really far-edged continuous delivery with intelligent deployments. Okay, so traditional deployments is like you do everything manually. You have to, you have your own data center. The deployments are big events in the company. Then you start evaluating continuous delivery, where you start kind of looking into the cloud, like what can you use from the cloud, where you still have some outages, of course, because you don't have the full DevOps mentality. You might still have silos, but at least you're making steps. You're taking steps towards continuous delivery. And once you get into continuous delivery, you see that instead of more than 10 manual steps, you now only have 1 to 3 manual steps. You might have this big red button that the manager has to press. And it only takes a couple of hours to deploy instead of, it's only a couple of hours to get from an idea, or to commit something to Git, for instance, and have it deployed. Okay, so the lead time is much shorter than here, for instance, weeks or months. And you can do a lot more deployments. Continuous deployment is often what we are currently doing, or at least without if you still have the big red button, but you can have the full DevOps culture, then you're probably still here as well. Continuous deployment is possible. Okay, and then you have no manual steps anymore. You can have hundreds of deployments per day or per month. And then intelligent deployments is what I was talking about today mostly. It's about this canary analysis. It's about automated rollbacks. It's about chaos engineering, all that cool stuff, and having predictive analysis. So monitoring also to the next level. And that's really the Valhalla, where you want to be. Okay. If, of course, your company can culturally get there. So I have 13 minutes left for a demo. Does anyone know Rick and Morty? Rick and Morty. Yes, great. More people than I expected. Awesome. My demo will be a little bit about Rick and Morty. I wanted to do blue-green deployments, but a demo with a blue and a green screen is so lame. So I used something from Rick and Morty instead. So if you want to follow the demo, you can by going to this website on your mobile phones, or this IP address if you'd like. And normally, currently, if you go to this website, you'd see a blue screen, because we're doing a blue-green deployment and we're currently in the blue version. I hope it's working, otherwise, if this doesn't work, it's gonna be pretty bad. So Rick and Morty is, hold on, let me mirror my screen. Yeah. Wait. Didn't work. All right. Okay, I have to stop the presentation. Is it working? Yes. This is Rick and Morty, right? Okay, so if you go to our current application on production, boom, 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 it's blue. Mr. Meeseeks, right? You know Mr. Meeseeks? I'm Mr. Meeseeks, right? Okay, if you don't know Rick and Morty, this might sound really ridiculous. Anyway, we have a little demo application. I hope this zooming works. Yes, great. It's simple Spring Boot. For blue pages and green pages, you don't need Spring Boot. I know, but at least it's something more. It's something more familiar to what we are going to deploy, and not just some super simple application, which is not really representative. So here you can see this is my Meeseeks image, and it's being shown in the demo HTML. Okay, so not really advanced stuff. Okay, but I will change this. Okay, I will make a change. So I will now switch it to Pickle Rick. Switch to Pickle Rick. Okay, so I made a change now, and now I'm going to go through pipelines. Okay, I'm going to go through Spinnaker, which will do a lot of stuff to get this deployed. So what I have is I have Google Cloud Platform where I deployed this on. You can check any cloud provider. And I have some build trigger here, which will automatically build my application, Maven, and then Docker. And it will push it to the registry. As you can see, a build was triggered here, and it will eventually be here in the images. Okay, so what will happen then? Let's see, I think I still, yeah, I don't have connection. Okay. So I'm SSHing into the Spinnaker installation, and I'm setting up a tunnel. Okay, so now I can start demoing Spinnaker. Okay, so this is Spinnaker. And I will zoom in a bit. Is this readable in the back? Yes? Great. So here, as you can see, I have a production cluster and I have a staging cluster. In the production cluster, I have 4 instances, and they are load balanced on this IP. And this IP is now blue. Okay? I also have a staging account, a staging cluster with just 1 instance. And just to make sure that everybody understands what I'm doing here with clusters, there's a different abstraction model than most clouds, just because it wants to use a common language. So you have applications, which are the top level. And my application here is called Spinnaker Demo. And I have set up something here, for instance. I have made sure that there's a traffic guard. So on production, to make sure that I don't do any deployment, which will erase all my instances, I set up here that I want to have at least 1 instance on production. For my production cluster, I want to have at least 1 production instance left at all times. Okay, so that's a feature that's pretty useful. So in my cluster view, I have now, oh, it's already starting to deploy. Whoops. Let's go back to pipelines, to be quicker. So my pipelines here, as you can see, there's a bunch of pipelines. I will start to deploy to staging first, just to have a test whether this is working correctly. So here, my deployment, what does it look like? It has a trigger. So the configuration says that, is this not readable? Okay. So the automated trigger says, go look in my Docker registry, go check for that Docker image, and if there's an update on any tag, whatever, then start triggering this deployment using this Docker image. Okay, straightforward. Then I want to deploy this to staging. So what does this do? It actually takes a, it takes some kind of, this is on Kubernetes, so you'll see some details from Kubernetes sometimes coming here because it's specific to Kubernetes. So I'm selecting this container, tag result at runtime, and I'm using a strategy called Highlander. Does anyone know why this is called Highlander, or what you might expect of a Highlander strategy? There can only be one. Right? So we cut off the heads of all the different instances. Right? No Highlander fans? Okay. So you can also choose other ways, so red, black, the blue, green, custom. You can define your own strategy that can be reused across different instances or different deployments, or no strategy at all. There will be here rolling blue, green, and canary at the end of the year. So we will deploy to the cluster staging, and we will use this load balancer. Okay, so we'll keep in the same load balancer. So what I see here in my pipeline is that the deployment has triggered. I deployed in default. The task status here is that it's completely should be finished, so it will be updating here to succeeded pretty soon. Then here, disabling of the old cluster. So if I go look here, the old cluster is being disabled, version 5, and version 6 is the new one. So if I now go to staging, and I go look at that instance, which color should it be? Green, right? Hopefully. Should work. So, ta-da, green, pickle Rick. Right? The previous one was blue. So on production, you're still seeing this. On staging now, it's switched over to green. Okay? So this you can't see yet on the app because you're looking at production, or on the website. Okay, so now the cluster will be removed. It's disabled, but it will be removed in the final stage of this pipeline. Let's take a look how that's going. Shrinking the cluster. It's still going on. Yeah, we'll continue with the next pipeline as this is going on. So the pipeline here deploying to staging was just deploying this to staging environment. The next step is I want to have a manual verification whether this is working or not, because I don't want continuous deployment yet. You might automate this, but I want to verify as a manager that this is actually the green pickle Rick and not the blue Me6. Okay, so I have a validation phase here. So the configuration is simple. It's a pipeline which takes the Spinnaker demo application and it looks to the previous pipeline. If that pipeline was successful, so if the deployment to staging was successful, now I will do something, which this pipeline obviously configured, the manual judgment. So the manual judgment is just a yes or no button, true or false, and it's verifying if the new functionality is actually working. That's something I should do as a human. And the human part here, even if you automate everything, could still be useful because it's the gut feeling that machines don't have. Okay, as a human, you might still sense that something's wrong. Okay, maybe your script doesn't really take into account all the different factors that, as a human, you might think of, based on experience, for instance. Okay, so having this button there, it might still be a good idea. All right, so I should normally see this now. Voila. So it's finished this pipeline here. It's green, succeeded. And now I have this little guy here asking me for a manual judgment. So I can now continue or stop. Okay? Let's continue. Great. Oh no, okay, so now it's green, right? So what should it do now? It will trigger the next pipeline. Uh-oh, I was too fast. So what does this do? It finds the image from the cluster, from the staging cluster. This is useful because if you have a lot of different pipelines going on at the same time, and you have a lot of different instances on this cluster, on the staging cluster, then making sure that your pipeline can dynamically itself find out which instance that you need, which image based that was used for this instance that you need is really powerful. So finding this image is baked in by default. Okay, so we are going to find this image, which is really quickly, it found the image. Then it's going to deploy a canary. So it's going to deploy a separate cluster where I can put more logging on, more metrics on, more alerting, whatever. And for that canary deployment, I want to use a new version. But mind you, the existing cluster on production is not being touched. Okay? So here, the deployment has finished. And now if I go to clusters, I now see a new cluster here, canary cluster. And that canary cluster has just one instance. Now there's another, the pipeline has halted because there's another manual verification I put in. So, people, now you're gonna have to help me. If you go to the app or to the website, could you refresh your page and put it in the air? All right, yes, I see mostly blue and some green. Yes, awesome. So if you refresh a couple of times, you'll see that it's just loading again. But it will load balance, of course, over the 4 instances that are of the existing Me6, the blue one, and 1 instance of the green one. Okay, so you see this is pretty straightforward. You might want to put this on a separate load balancer, but just for these testing purposes, I put it on the same one. Okay, so as you can see, the canary is successful, and I now want to say, okay, let's continue. Okay, I'll just go on, and if you look at the next steps, there's the cutover manual approval. So I cut over because I was happy with the results. You guys, great crowd, awesome, thanks. And now I'm going to do a blue-green deployment. So I'm going to deploy the new version, and the other version will be made disabled. It will be disabled. I won't remove it because I want to have an easy rollback in case something goes wrong. Okay, so if I go to clusters, I should normally see here a new one. This might take some time. That's right. Version 4 has come up, and it will deploy 4 instances of Pickle Rick, the green one, in this cluster. Okay, and these will then be disabled. After some time, it will do the next steps of the pipeline, which are, so this is the blue-green deployment. I will tear down the canary because I won't need the canary anymore because we blue-greened the production cluster, obviously. Then I will wait 2 hours, but we won't wait 2 hours, right? We'll just wait 5 seconds, right? And then we'll, at the final step, we'll destroy the old server group. So there are no more ME6 around. Okay, so that's kind of the scenario here. That's the demo. Normally, I think I'm out of time. So we can maybe, hopefully, finish this pipeline. As you can see now, they're both there. So if you're refreshing now, you'll see that there's like a little bit more chance to get the green than to get the blue. And it will make this now, it will disable it now and then delete the old instances. Okay, so that's kind of the wrap, I suppose, for the demo. So if you guys have any questions, I think I'm out of time and they'll kick me out, but I have a shameless plug. I have stickers. So if you guys want stickers of Spinnaker, these are very rare in Europe because not many Netflix guys actually come here. So I asked Andy Glover, the developer manager of Spinnaker, to send over some stickers, and he sent me like thousands of stickers. So please help me out and take some stickers. And if you want, you can also get some Netflix stickers. So anyway, thanks everyone for the time. And this has now become disabled, right? And hopefully I'll see you tomorrow or in this evening at the conference. So if you have any questions, reach out to me. Thanks.